The next rule that we look at is what we call the product rule. And that's what we use when we have two functions multiplied together. The formal definition is that. So differentiate u and v, and u and v are two functions, and you go u, v dash plus v, u dash. Much easier to think of it this way. Write down the first and diff the second, plus write down the second and diff the first. That's the product rule. Write down the first, diff the second, plus write down the second, diff the first. The reason I like it, same as that last one, is you're sort of saying what you're doing, so you can say it as you do it. Yeah. Let me show you what I mean. I've got x to the power of 7 times x to the power of 9 minus 6. It's really hard to come up with an example here where you can see the advantage of using the product rule, because we haven't looked at a lot of functions yet, or we don't know how to differentiate, say, trig functions and all that sort of stuff yet. Of course, I could just expand this out and differentiate. It's a very easy one. But here, without expanding it out, here's I found the derivative. Write down the first. Oh, okay, x to the power of 7. Diff the second. Well, if I differentiate x to the power of 9 minus 6, I get 9x to the power of 8. Plus, write down the second, x to the power of 9 minus 6. Diff the first. Oh, well, if I differentiate x to the power of 7, I get 7x to the power of 6. Tidying that up, and you can see why it looks a bit silly. Why would you use that? Because I'm going to have to expand out anyway. Why didn't I just expand out at the start? And possibly for a question like this, the product rule is a bit silly. But as I say, it's hard to come up with examples at the moment until we've seen some of the other functions. So here's a binomial. Again, yes, of course, I could expand the whole thing out. But I could go, write down the first, x minus 2, diff the second, 2, plus write down the second, 2x minus 3, diff the first, 1. And tidying that one up, we get, there it is, 4x minus 7. Okay. Using this notation, all that means is differentiate what's inside the bracket. So we're saying differentiate this whole function with respect to x. If I use this notation, I just simply go equals, because I'm saying the derivative of all of this is, write down the first, x to the 7 minus x cubed, diff the second, 6x, plus write down the second, 3x squared plus 7, diff the first, 7x to the 6 minus 3x squared. Expand all that out, tidy up, and we have an answer. Still probably quicker just to expand that out, to be honest. Here's one where it's not quicker to expand out. Because to expand this whole thing out, I'd have to work out x squared plus 4 to the power of 5, and that's going to take some time. So and this is cool because it combines the two rules we've seen today. Write down the first, 3x. Diff the second. Hang on, x squared plus 4 to the power of 5. I've got to use anarchy. Bring down the power, 5. Lower the power, 4. Diff the inside, 2x. Plus, write down the second, x squared plus 4 to the power of 5. Diff the first, 3. Wow. Let's tidy the first bit up. 3x times 5 times 2x gives me 30x squared. We got a common factor there of x squared plus 4 to the power of 4. Remember, whenever you're factorising, it's the lower power you take out. Also got a common factor of 3, which for some reason I haven't bothered taking out. Don't know why. I did it in the last step. Okay. Possibly quicker to do in the first step, doesn't really matter. It does eventually come out, and there is our answer for the derivative. In this case, the product rule is very useful because that will save us time rather than expanding the whole thing out first. Again, here, something where I have no choice because we'll square root of 2x minus 1, couldn't expand it out even if I wanted to. I suppose I could, I'm not suggesting you would do it this way, you could put the 2x back inside the third. What would that become? Oh boy, if I'm putting 2x back in, what I'm really putting in is the square root of 4x squared. So that would become 4x squared times 2x is 8x cubed minus 4x squared, the square root of, and you can see how mistakes could happen there. Let's use the product rule. Change the index form first, so 2x minus 1 is to the power of a half. Write down the first, 2x. Diff the second, oh, got to use my chain rule, anarchy. Bring down the power, lower the power. Diff the inside, diff 2x minus 1 is 2. Plus, write down the second, 2x minus 1 to the power of a half. Diff the first, 2x differentiate, become 2. Tidying that up. Now, there are common factors there. Just because one's negative doesn't matter. We still use the same idea. When we factorise, take out the lowest power. Negative half is the lowest number there. So I'll factorise, the 2 this time. I did take the 2 out straight away. So there's 2 in both. 2x minus 1 to the power of negative a half is in both. What's left inside? Remember, factorising is division. So if I divide 2x minus 1 to the minus half by this, I'm just left with x. The second one will be left with 2x minus 1 to the power of 1. Because it was power of a half, I've factorised out or divided by minus a half. When we divide, subtract the powers, half minus a half leaves me with the power of 1. And that tidies up inside there. There's a pretty good mere mortal answer. You've got to be pretty good to get at that stage, even if you are just a mere mortal. But we can go a step further. Oh, look at that. Isn't that nice? That looks so much nicer. Okay, so we'll play around with those two rules today.